Compared to when it was first launched, the PlayStation 5 has had a significant internal redesign, with the components like the motherboard being completely refreshed to be a lot smaller. The first challenge before making this a reality though is that the PS5 is more than its motherboard alone. It requires many extra components to make it work, most of which are dedicated just to keeping it cool, as it generates so much heat. Trimming all this down to a size that can be considered portable is going to be a monumental challenge, but where there's a will, there's a way. Take the main heatsink for example. It's a fairly weird shape and occupies a lot of space, but one action we can take is to swap it out for one that's much shorter and wider, though with approximately the same cooling capacity. As its base is solid copper, it can be easily drilled and tapped to add screw holes to it, which are perfect for using some aluminium lengths to mount it adjacent to the main motherboard, rather than on top of it, which makes for a shallower profile even still, particularly when compared to the original. But how on earth are we going to get any heat generated by the processor over to it in this configuration? Heat pipes, of course. Heat pipes, for those who don't know, are hollow copper tubes that have a rough texture on the inside walls. As they're normally sealed with a small amount of liquid inside, heat can be transferred very rapidly from one end to the other by the liquid literally boiling inside and condensing wherever it's the coolest, making them ridiculously good at moving heat around. The ones I've got are designed to be mounted to a little copper block, but unfortunately I can't just mount this block to the processor as is. You see, as the PS5's processor generates almost 200 watts worth of heat, it's necessary to use a thermal interface material referred to as liquid metal. And if I were to use this with my block, it would eventually absorb into the raw copper and stop working properly. Interestingly, the base of the original heatsink is copper as well, but Sony has nickel plated it, making it far more resistive to liquid metal absorption. All that's needed for this is some white vinegar and nickel strips, plus a dash of salt. By connecting the strips to the positive and negative terminals of a battery or a power supply, one of the nickel strips can be dissolved into the solution, giving us an electrolyte that can be used for electroplating. To use it, all we need to do is replace the dissolved nickel strip and swap out the other one for the block. This allows the nickel to be transferred from the new strip over to the block, giving us a nickel-plated finish. After a quick polish, this looks perfect, and it should now work reliably with the liquid metal. This stuff is like magic. It's literally molten metal, as it's made up of various components to achieve a very low melting point. Once it's been spread to both the processor die and the now nickel-plated block, the whole thing can be squashed together. As the surface area intended to be in contact with the heat pipes is pretty large, it's actually okay to go with traditional thermal paste here, after which the heat pipes themselves can be finally mounted in place. These have been carefully bent to go around various components and so that they spread out on the heatsink. And it looks pretty cool. With the processor now thermally linked to the heatsink, we're almost ready to test it out. But how are we going to move air over the heatsink to keep it cool? The original, rather gargantuan blower fan is simply out of the question due to its size. But what about using several mini versions instead? Using 4 of these in parallel multiplies their airflow output, hopefully to the point where they'll match the much larger fan. By positioning these new fans along one edge, they blow air underneath the console, and by taping the sides, the air has only one way out, through the heatsink. Now this of course looks super janky right now, especially with the power supply just perched on top, but it does allow us to operate the console and observe its temperature with a thermal camera. As soon as the console is on, we can see that the heat pipes start moving the heat over to the heatsink. Once a game is launched though, the console begins to draw its maximum power, and the temperatures continue to climb, with the block itself hitting over 60 degrees Celsius. It's safe to assume that the core of the processor will be even higher than this, so it's no wonder that after a few moments the console shuts itself down with an overtemperature warning message. Now, as the present heatsink fits very nicely on the side here, instead of increasing its size, I'm going to add an additional smaller heatsink instead to provide the extra heat dissipation surface area. Mounting it does require some modification of the heat pipe layout, but doing so provides the perfect opportunity to optimize things further by spreading them out more so that they go diagonally across the fins rather than parallel to them. allowing them to dump heat more effectively into the heatsinks. As for increasing airflow over the heatsinks, the cheap generic fans I used during testing just aren't anywhere close to being good enough. So, after some intense research online, I'm going to replace them with some highly engineered models designed for high-power laptops. Not only do these push more air while being quieter, but they're bidirectional as well, meaning that they can blow air over both heatsinks at once, despite the heatsinks being at opposite ends of the motherboard. Being on the back here, they can also cool the small components on the board too, thanks to some additional mini heatsinks and copper bridging pads, with some 3D printed air ducts to control the airflow. So, how well does this revision work? Well, rigging it up for testing reveals some legitimately shocking results. Not only is the console more than happy to run indefinitely with this new cooling setup, but it does so with a huge amount of headroom, with the block itself now hovering at just 42 Celsius at full load. This means that the speed of the fans can be ramped down significantly to the point where they make only a soft whirring sound, and I'll be doing some tests against a gaming laptop later so you can hear it for yourself. Sony's design language for the PS5 leans heavily into a high-contrast two-tone look, so taking inspiration from this, I've designed a shell that can be 3D printed. It's a little big to print in one go, so I've split it up to print in several separate pieces, with the intention of gluing them together. This technique allows some parts to be printed in different tones as well, providing the high-contrast black and white appearance, and I think it's ended up looking pretty smart. As the main body lacks a uniform perimeter for the shell to be fitted to though, it's necessary to add some aluminium trim to provide a robust frame. Even so, it's not quite time to put the shell on yet, as an important component needs to be considered: the speakers. You see, most portable consoles have some form of sound system, but they're usually pretty thin sounding and not great for a full gaming experience. So, to get around this, I'm going to include a miniature subwoofer consisting of two 5-watt drivers to fill in the low-frequency sounds, and I think it will provide some serious bass, especially being complemented by two stereo side speakers. Now, making speaker enclosures at this scale isn't particularly easy, and I have to admit they don't look very neat, but that's okay because the intention is to cap them off with the remaining 3D printed trim. With that done, the shell can now finally be lowered on top to hide all of the internal components, which suddenly makes it look a lot more complete, with a subtle but definitely present PlayStation vibe. And with the help of a little kickstand, it is indeed starting to look like a tablet. Granted, it is a little on the chunky side, but do keep in mind that there's a full PS5 inside here. And when compared to the original console, it's actually quite remarkable how much we've been able to shrink it down. This size advantage remains even when compared to the PS5 Slim, which is the thinnest official PS5 to date, which is very satisfying. Now, you may have already heard of DarkPlates 2.0, Dbrand's popular replacement side panels for the PS5. They are slim, feature built-in vents for improved cooling, and lose the popped collar look that personally I've gotten a little bit fed up of. You can also inject a bit of your own style by picking from a selection of designs for the middle skin. I've got one of their new skin options, which are real X-ray scans of the PS5's internals, allowing the engineering to be shown off. Here we can actually see the coils and transformer in the power supply, as well as the heat pipes and their accompanying fins. They've actually scanned a load of different devices too. I've got one for my phone, which makes it a lot more interesting to me, as things like the USB port and internal speakers are made visible. Easy to install and is a great way of protecting it, as the screen is pretty exposed, especially when it's shoved into a bag. Now, the problem with LCDs, and why I don't really want to use one, is that they suffer from motion smearing and poor black level performance. So instead, let's go with OLED. These provide pixel level dimming for incredibly vibrant images, but as they're still a bit hard to get hold of in panel form, I'm salvaging mine from a busted laptop. There's really no contest when it comes to image quality here, with the OLED panel being in a league of its own for sure, with a much brighter and more vivid image, with no motion smearing. Top tier performance for a top tier console. As the display itself is so thin though, I think it's a good idea to reinforce it with a super stiff custom cut carbon fibre back panel, which protects it from bending if it were ever to be pushed in the middle. This finishes off the unit beautifully, and it finally looks like a real product. But before I can test it out, there's a bit of an elephant in the room. How on earth is it going to be powered? Despite its high power capability, it's actually smaller than many laptop power bricks, so is a good choice for this project. To hook it up to the PlayStation, instead of going with plain paired wire, which is ugly, not to mention stiff, my plan is to get a single core of large gauge silicon wire to carry the positive voltage supply and sleeve it with copper for ground, making for a highly flexible, low resistance power cable. After adding some custom high current connectors, it can be finished off with some beautiful silver and white sleeving, which matches the aesthetic of the unit nicely. This can now be plugged into the back of the PlayStation, completing the build. It's taken so much effort to reach this point, but it looks amazing. My first impression is the brilliance of the screen. Being OLED, it of course has inky dark blacks for vibrant colour rendition, but as it's full 4K as well, it really takes advantage of the PS5's insane rendering power, and it looks incredibly sharp. 4K portable gaming? Man, this is pretty unique. The best thing about this form factor is that it's portable enough to actually be a social experience. You're not bound to a TV. This is in stark contrast. More remarkable is just how quiet it is. Thanks to the large heatsinks and 3 bi-directional fans, it makes far less noise than you'd expect. Here's a comparison to a high-end laptop that doesn't even draw as much power. So while it's definitely audible compared to a full-sized PS5, it's not bad at all, especially considering it's so portable. And I'd say mission very much accomplished. Now I think if Sony themselves were to make a console like this, they could probably make it, because really this is just a PlayStation 5 plus a screen. The extra components are just in a different form factor.